Hi, I'm Tommy, a guy who wants to share some cool stuff with you guys. Thank you for supporting the channel. Right now, something just hit the AI world that changes how fast machines can think back at you. NVIDIA's Groq 3 LPX just entered full production, and the numbers are wild. 3,400 tokens per second at 100,000 token context. On an open model, that is not a small upgrade. That is a different speed of reality. But the real story is far bigger. What actually is the NVIDIA Groq 3 LPX? It is a dedicated interactive AI inference accelerator. Think of it as a specialized engine built only for the moment an AI model turns its understanding into words, tokens, the little pieces of language that stream out as answers, code, plans, or agent decisions. Most of the heavy lifting in AI still happens on giant GPU clusters. Those chips are incredible at training models and at the first big pre-fill step where the system digests a huge prompt or context. But once the model starts generating the reply, token by token, a different bottleneck appears. Memory bandwidth, the speed at which data can move inside the chip. That is where the Groq 3 comes in. Each chip is a language processing unit, or LPU. It packs about 500 megabytes of ultra-fast SRAM right on the die, not the big HBM stacks you see on GPUs. SRAM, the kind of memory that is blisteringly quick, 150 terabytes per second of bandwidth per chip. A full LPX rack packs 256 of these LPUs together. That gives you 128 gigabytes of total SRAM and a staggering 40 petabytes per second of on-chip bandwidth. Scale-up bandwidth across the rack hits 640 terabytes per second. The whole thing is liquid-cooled and designed to sit right next to NVIDIA's new Vera Rubin NVL72 systems. NVIDIA did not invent this architecture from scratch. In December 2025, they paid roughly $20 billion for the core technology and talent from the company Groq. Founder Jonathan Ross and President Sunny Madra joined the effort. Samsung builds the chips on a 4-nanometer process. The result is the 7th chip in the Vera Rubin platform family, GPUs and LPUs working together. Rubin GPUs handle the massive context and compute-heavy layers. The Groq 3 LPX handles the pure speed of generating the next token and the next and the next. Why did this just break the internet? Because Artificial Analysis, an independent benchmarking group, ran the open-source Gemma 431 billion parameter model at a full 100,000 token context window. The NVIDIA Groq's 3 LPX system delivered a median of 3,431 output tokens per second. NVIDIA rounds it to 3,400. That is nearly 4 times faster than the next public endpoint on the same test. For coding-style agent workloads on SpeedBench, the number climbs even higher, median around 4,767 tokens per second. In practical terms, generating 5,000 tokens drops from roughly 50 seconds at 100 tokens per second down to about 1.5 seconds. Agentic tasks that used to take hours can now finish in minutes. This solves a very real problem. Agentic AI systems do not just answer once. They plan, call tools, read files, write code, test it, fix it, and loop. Every loop burns tokens. If each step is slow, the whole agent feels laggy. Users abandon it. Enterprises cannot trust it for time-sensitive work. The Groq 3 LPX attacks exactly that latency wall. It keeps high throughput, even as context grows from 10,000 to 100,000 tokens. The system stays stable, no big drop-off. That predictability matters when you are orchestrating dozens of agents at once. The good impacts are already starting to appear. Cloud providers like Nebius are first in line to deploy these racks in their Token Factory service later this year. Groq itself is bringing the hardware into its own inference cloud. Developers will feel it as coding assistants that stay in flow instead of making you wait. Research agents that can hold an entire code base or a long conversation history and still respond instantly. Enterprise systems that can run multi-step reasoning without the cost of idle human time. NVIDIA claims the combination of Vera Rubin plus LPX can deliver up to 35 times higher throughput per megawatt for trillion parameter models compared with previous generations. That is not just faster answers. That is more economic AI. More revenue opportunity for AI factories. More room for agents to become everyday tools instead of expensive experiments. Of course, there are downsides and risks. This hardware is not cheap or simple. You need racks of LPUs sitting next to GPU racks. The architecture works best when you disaggregate the workload. Prefill on the GPUs, decode on the LPUs. Not every model or every workload will map perfectly yet. Some experts note that the headline 3,400 tokens per second is measured on a relatively modest 31 billion parameter dense model. Scaling the same efficiency to much larger mixture of experts models or multi-trillion parameter systems will take more engineering. Power and cooling still matter at rack scale, even if efficiency improves. And concentration of advanced inference silicon in fewer hands raises the usual questions about access, competition, and who gets to run the fastest agents. There is also the simple risk of over-promising. Token generation speed is only one part of an agent's total time. Tool calls, external APIs, and verification steps still sit outside the pure inference loop. Looking forward, the way this should develop is clear. Keep the co-design tight between Rubin GPUs and Groq LPUs so the handoff stays seamless. Open the software stack further so more model families and more frameworks can exploit the disaggregated path. Push the same low latency philosophy into smaller form factors and edge deployments once the data center economics are proven. And measure success not just in peak tokens per second, but in end-to-end task completion time for real agent workloads. If the industry stays focused on that user-facing speed and reliability, the next wave of AI agents will feel less like slow chatbots and more like sharp collaborators that keep up with human thought. 3,400 tokens per second at 100,000 context is the number that just landed. But the deeper shift is this. The gap between asking a machine for help and receiving useful action just got dramatically smaller. Your coding session, your research loop, your multi-agent workflow can now move at a pace that matches the speed of your own ideas. That is what the NVIDIA Groq 3 LPX actually is. And that is why the timing feels so electric.